So sometimes covalent bonds can form as a coordinate covalent bond. And what this means is that the electrons both come from a single atom, and the other atom has just a vacant orbital that is used for the electron sharing. So a typical or traditional covalent bond that we've been talking about, each atom in the bonded pair is contributing a single electron to that sharing pair. And so atom X is sharing one electron with atom Y that's sharing one electron with atom X to equal the shared pair of electrons. In a coordinate covalent bond, the electrons are both going to be donated by a single atom that's going to share them with an atom that doesn't have anything to share in that area. They just have a vacant orbital. And so both electrons become contributed in the shared pair from a single atom. These are known as coordinate covalent bonds. And they become important when we start thinking about some of our polyatomic ions. Ammonium is a great example of a coordinate covalent bond. So if we look at the nitrogen molecule, if we look at the periodic table, this is in group 5. So it has 5 electrons in its valence shell. So it's got 1, 2, 3, 4, and the 5th one is in this lone pair of electrons. So this lone pair of electrons actually is taking up space, and it's taking up this orbital area here. So sometimes when we have an acid present, we saw that the acid can dissociate and hydrogen is acting as an ionic compound at that point. And so when hydrogen is acting as a cation, it loses its electron. It leaves it with the chlorine in the hydrochloric acid, for example. And so when it dissociates in solution, like ionic compounds can do, it's just going to leave that proton floating around there. And so its electron orbital is empty. And so this positive charge, this proton, gets very attracted to the electrons that are floating in this orbital by the nitrogen. And so this hydrogen will come over and it will sit on top of these electrons because it's attracted to it. And so this forms a coordinate covalent bond then with the nitrogen. But because it doesn't bring any electrons into the bond, it only brings a proton in, there is a net positive charge on this entire molecule. There's one more proton present than there are electrons. So remember, when we have the electrons and the protons are completely balanced in this one, when these hydrogens come in, they bring one proton and one electron to their bonding partner. When this one comes in, it's not bringing any electrons with it. It only brings a proton. So that H plus positive charge is going to sit down here, and that positive charge gets distributed throughout this entire molecule. So coordinate covalent bonds then are very important for a lot of transition metal chemistry to occur as well. So they often form coordinate covalent bonds with nonmetals.